Hi, this is Nancy Mansell coming to you from CNN Behind the Glass. Now let's look at solving systems of equations by substitution. Here's a system. What does equal mean? Equal means has the same value as. So if x has the same value as y plus 2, I should be able to take that and substitute it into the second equation in place of x. So let's do that. 2 times x's new name, y plus 2, minus y, equals 6. So what did that buy us? Well, now we have only one variable in this equation, which means that we can solve it fairly easily. Distribute 2y plus 4 minus y equals 6. And collect like terms. 2y minus y is y, plus 4 equals 6. And subtract a 4 from both sides, and you have y equals 2. So are we done? No, remember, this is a system of equations. The fact that I was able to solve to y equals 2 tells me that these lines do cross, but we have to know where they cross, and so far all we have is the y, we don't have the x. So we should go back to one of our original equations and plug in y for 2 and solve for x. This one looks like it's going to be a little easier to me. So x equals, plugging in 2 for y, 2 plus 2, looks like x equals 4, which would make our solution 4, 2. It's pretty easy to check these, so let's go ahead and do so. Let's plug 4, 2 in for x and y into both equations and see if it checks. Okay, so x is 4 equals y is 2 plus 2 gives me 4 equals 4, and it checks in the first equation. Now let's try this in the second equation and make sure it checks there as well. 2 times 4 minus 2 equals 6. 8 minus 2 equals 6. 6 equals 6. So it checks in the second equation as well. And you can be sure that the correct answer is 4, 2. Okay, let's try another one now, one with fractions. I know how much you love fractions, so let's do one with fractions. Here's a system of equations, and we're going to solve it by substitution. But the first equation has fractions in it, and we hate fractions, right? We just hate them. So if you could do an extra step to get rid of the fractions, would it be worth it to you? I think that for most of us the answer would be yes. So let's go ahead and clear the fractions on the first equation. My denominators are 2, 3, and 6. 6 is the largest of them, and 2 and 3 both go into it. So let's multiply everybody in the first equation by 6, and that will kill the fractions. 3 goes into 6 twice, and 2 times 2x is 4x. Minus 2 goes into 6 3 times, and 3 times y is 3y. And the 6's cancel here, and it leaves me a 7. Okay, so now my system doesn't have fractions in it anymore, and I think you're probably a whole lot happier than you were 30 seconds ago. So what we're looking for now is an isolated variable. We had an isolated variable in the last problem, but this one does not have an isolated variable, so we're going to have to isolate one. This would be the easiest thing to isolate because it has a coefficient of 1 or negative 1. So we're going to have to do a little work on the side here on this equation to get the y by itself. What if we subtracted 3x from both sides? We'd have negative y equals negative 3x plus 6. So is the y isolated yet? Not quite. We're going to have to divide everybody by negative 1 first, and we'll have y equals positive 3x minus 6. Okay, now that we have an isolated variable, and remember, it was this equation, right? We can take this and plug it in 4y into the other equation. Okay, then we'll have 4x minus 3 times y's new name, 3x minus 6, equals 7. Notice we have only one variable now, x, so we should be able to solve for x. 4x minus 9x plus 18 equals 7. And collect like terms. 4x minus 9x is negative 5x plus 18 equals 7. What do you say we move the 18 over? We'll subtract 18 from both sides, and we'll have negative 5x equals negative 11. Then just divide both sides by negative 5, and we'll have x is positive 11/5. So, are we done? We have the x, but we need the y that goes with it. All right, pick either of the original equations. It doesn't matter which. I think the one that didn't have a fraction in it will be easier. And we're going to substitute 11/5 for x and solve for y. So 3 times 11/5 minus y equals 6. 33/5 minus y equals, I'm going to go ahead and turn this into a fraction so I have like terms. I'd like my denominator to be 5. So 5 times 6 is 30. And 35ths is the same as 6. Agreed? Okay, let's continue. We're going to subtract 33/5 from both sides, and we'll have negative y equals negative, that's a 3, negative 3/5. Okay, very good. Now what? Divide both sides by negative 1, and y equals positive 3/5. And now we have our answer. It's 11/5, 3/5. Good job. I didn't leave myself room to check it on the board, so you'll have to check it yourself, but I assure you it is the right solution. Have a great day. See you soon. Bye.